logic, he had go here. He had the concept of a Boolean okay, so what is wrong with my pen? It doesn't want to write. Try again. Okay, think. Let's see. Don't think I don't know if I'll try with my mouse, right? So I'm not sure what's wrong with the pen. So let me go here. So he had the concept of oops, it's not gonna go well. Luckily, I don't have to write a lot. So Boolean logic, right? From Boolean algebra, we're just focused on this piece, and he had a very simple concept. On, something was either on or off. And since computers understand, so if it was on, it was number 1. If it was off, it was 0. If it was on, it was true. And if it was on, it's false, right? So the computer understands 1, 0. For us humans, we use true, false, because that makes more sense to us. And he created the concept of Boolean expressions, right? So there was Boolean logics, and then from on off, we could work with Boolean expressions, which is any expression that returns true or false, right? Luckily, this is all I have to write. The rest will be examples, okay? So any expression that returns true or false is a Boolean expression. If this, so if this, then this will be either true or false, right? So, but he created the concept of and, or, and not, which I'm pretty sure you remember from building code in Python, right? So if there was an X and then there's a Y, then there's a result. And in AND, if X is true and Y is true, then the result is true. If X is true and Y is false, then the result is false. If this is false and this is true, then the result is false. And if this, obviously if this is false and this is false, then false, right? So X and Y have to be true for ANDs to be true. In a real world scenario, not thinking about programming, if you're a parent or if you were younger and you were a kid, right? You were asking permission to go somewhere, and then your parents would be like, well, if your room is clean and you washed your laundry, whatever, right, then you can go. Those two conditions have to be true. If one of those two conditions is not true, then the answer is no, you can't go, right? So that's how AND comes into play for programming. Oh, there we go, my pen finally worked. Okay, good. Okay, so then his other contribution was the OR piece, right? So there's X and Y and some result. So if X is true and Y is true, then we have true. If X is true and Y is false, then we have true. If X is false and Y is true, then we have true. And if we have both of them false, then the result is false, right? So, and finally negation, right? If we have some X, then we have some result. So if true, but not true, then we have false. And if we have false but not false, then we have true, right? So we invert it. And usually we write T or F or 1 or 0, right? Whichever one. Like like if you get an assignment and I'm asking you to write the truth tables, then you can use T's or 1s and 0, TF or 1s and 0s. It doesn't make any difference to me as long as you understand the concept. And please make sure you memorize these tables to make sure you don't miss points on quizzes or exams, right? So if you're just wondering the easy way to remember this, just remember that and both of them have to be true for the result to be true, and or both of them have to be false for the result to be false. And then this one's always the opposite, right? So not true, false, not false, true. So if I create one more page here and we look into first and I'm like true, 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 there's one false, then the result will be false, because in and everything has to be true. And for or we can have false, 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 but as long as we have one true, then the result is true. So if you're wondering why I'm going over this, this will help you build expressions for conditional statements and if statements or loops, right? Usually like there might be 1 or 2 conditions, but if you're working somewhere, then you might need like compound conditions, right? Like 1, 2, 3, and or and, right? So depending on what you're building, if you know the truth tables, then you don't have to be guessing. You don't have to be like, okay, let me type this. Afterward, I'm going to run the code and I'm going to see, right, like what happens. So you write it correctly, then you write the test case just to validate that you did it correctly. So, and of course, negation, we don't have to worry about here because it's always the opposite. So, any questions here? Okay, so no questions. So let me jump back here. So what we're going to do next is we're going to prove that C++ and or and not are built into the language, right? So in C++, we use the symbol, let me see here, ampersand and ampersand for and for or we use the 2 pipes, I think they call them, and then for not we use not, right, the exclamation point. So anytime you see symbols like this, then you should be able to be like, oh, okay, so they're using Boolean logic in this case. So let me